The example is a rigid body AB of 40 kN hangs from the 3 wires. So there is body of 40 kN and hanging with 3 wires. So this is first wire, the middle one second, and third one. The middle wire is of steel, that means this wire is steel, and 2 outside wires are of copper. 2 wires of copper. Each cross section area of each wire is 250. So area copper is 250 mm square. AC equal to 250 mm square, and area steel equal to also 250 mm square. Now we have to find out, calculate load shared by each wire. That means P1, PC and PST. Here also modulus of elasticity for steel is 210 GPa and modulus of elasticity for copper is 120 GPa. So given data is P is equal to 40 kN, that is 40 into 10 raised to 3 Newton. Then length of each wire is same. So L1 equal to L2 equal to L3. Then the area for copper is 250 mm square and area of steel equal to 250 mm square. So we can replace this length for copper LC equal to length of steel wire. Then EST is 200 GPa, that means 210 GPa is equal to 210 into 10 raised to 3 Newton per mm square. Then E copper equal to 120 GPa, that means 120 into 10 raised to 3 Newton per mm square. And we have to find out load shared by the copper wire and load shared by the steel wire. For that, our first condition, now this is the composite section. So here first condition, P equal to PC plus P steel. Now there are 2 wires of copper and 1 is steel. So here P is 40 into 10 raised to 3 Newton is equal to PC means sigma 1, or we can say sigma C into AC plus sigma steel into area of steel. We have sigma equal to P upon A. So from this equation we can calculate P is equal to sigma into A. Now we have to first calculate sigma C and sigma steel. So 40 into 10 raised to 3, sigma C is unknown. Here area C is 250, but there are 2 wires. So 250 plus 250, so that is 500 plus sigma steel into 250. So we will give, this is the first equation. Now second condition is length, change in length equal to same, equal to delta L C equal to delta L steel. Therefore PL upon AE, so load by copper, length of copper, area of copper and modulus of elasticity of copper equal to PS LS upon AS ES. Okay. Now this PC upon AC means sigma C and LC equal to LS. We have already mentioned here LC equal to LS. Therefore this will get cancelled. So sigma C upon EC is equal to, here also, sigma S upon ES. C equal to we'll get EC upon ES into sigma S. This relation is important and it is second equation. Now, what is EC? EC is given 120 GPa. So 120 into 10 raised to 3 upon ES is what? 210 into 10 raised to 3 sigma S. So we will get sigma C equal to point is equal to 0.57 sigma S. This is the important relation. So we have to put this sigma C in equation number 1. So we will get 40 into 10 raised to 3 is equal to 0.57 sigma S into 500 plus 250 sigma S. By solving this, into 10 raised to 3 is equal to 7 into 500 means 285 sigma S plus 250 sigma S. Therefore 40 into 10 raised to 3 and it is 285 plus 250, that is 535 sigma S. So from this we will get sigma S equal to 40 into 10 raised to 3 upon 535. So sigma S is 74.76 Newton per mm square. Now put this sigma S in this relation which we have already got. Sigma C equal to 0.57 sigma S. So it is 0.57 into 74.76. So it is equal to 4067 Newton per mm square. Now we have to calculate the load shared by each wire. So now this sigma S and sigma C we have to put in this equation. That is, if we take PC, load shared by the copper wire, so PC equal to sigma C into AC. So sigma C is 42.67 into 500. We will get load shared by the copper wire, and that is equal to 21,335 Newton. Okay. Now calculate this load shared by steel wire, and that is sigma S into AS. Sigma steel is 74.76 into area of steel 250. So we will get answer 667.50 Newton per mm square. So this is a very simple example of this composite section. Thank you.